22. What we're going to do is just look at these fractional exponents, which is something new and something different. Kind of looks a little weird. However, you already know how to do this. This is going to be something similar to when you used to do this, and say like 8 divided by 2 and it equaled 4, right? And then when you got to algebra, you really stopped using this division sign and you just did 8 over 2 instead. But they mean the exact same thing. That's kind of like what this is. You already know how to do this, you just don't know this format. Okay. So the answer here is 4. Okay. The answer here is 9. Okay. So what function is this? The same as? Yeah, it's the same as square root. 1/2 power is the same as the square root. So, listen up, please. So all three of these right here are equivalent. So if I said the square root of 16, or 16 to the 1/2, or even 16 to the 0.5, they're all equivalent. Okay, so you know how to do this. It's just a different symbol, different way of writing it. Okay, so the first page here is just getting used to the basics. And if you extrapolate, if the 1/2 power is square root, the 1/3 power logically means it's a cube root. So the cube root of 27, you know, equals 3 because 3 times 3 times 3 is 27. So 27 to the 1/3 power is also 3. Not divide, no. No dividing. Because 27 divided by 3 is 9. That's not equal to 3. But the third root. So what times itself 3 times equals 27. So go ahead and try a few of these and see how you do. You'll find it very intuitive because you actually know this better than you think. Okay? And then, alright, so stop there. So number 5, it really 6, 7, 8. They just really take 2 of these problems and put them together, and you just have to add or subtract the final answer. Now remember that back in the day when you first learned order of operations, there might have been square roots in there, and the teacher just told you, well, just do them at the same time as exponents. And now you know why. It's because exponents and square roots are actually the same thing. So whenever you come across exponents, just think of square roots as being the same thing, do them at the same time. So when we get here, I actually initially look at this and you just get used to saying square root of 49. Even though it says to the 1/2 power, just think that's square root because it's a 2 on the bottom. So square root of 49 is 7, square root of 4 is 2, and then if just like always, order of operations, we did exponents, then do subtraction. Ready? Now, yeah, so the rest of these, let's go down to the last row. It's just more order of operations. So we have 9 to the 1/2 power, so it's in parentheses. You're going to do the parentheses first, and then do the exponent next. So don't change anything as far as order of operations. Do it as you always have. So square root of 9 is still 3. And then 3 to the 3rd power is 27. Square root of 16 is 4. And now do the exponent. 4 to the 3rd power is 64. Okay. So finish up this side and then we'll move on shortly. Okay? You can see how easy these are to solve when they're broken apart when you have two exponents, because, well, I know I need to do this first, then I need to do this second. It's very logical from inside to outside what you need to do. Now, starting on the next page, it's not broken up for you yet. So you remember, if you have an exponent raised to an exponent, or a power to a power, like 5 to the second power to the third power, that's the same as 5 to the sixth power. Multiply them out. So if you have two exponents, you multiply them, that's a more simplified version. So the same thing here. If you multiplied these two, it's going to be 9 to the 3 over 2. Right? So this is already broken up, so it's easier to see, like, well, 3 over 2 is just really to the 1/2 power and then raised to the third power. It's 2 steps, but it's just one number here. So that's what you want to do for the next one, is you want to take them and break them up into 2 steps, so it's not just one number, but 2 numbers. And really, it's just the top number, the numerator, being removed to the outside. So let's look at here. Right here. So for instance, if you want to do 4 to the 3 over 2 power, break it up into 2 steps, make it 4 to 1/2, right? And then just take that 3 and put it on the outside. Right? So this is 2 to the third, which is equal to 8. When you have just a fraction exponent, it's really 2 different things. It's weird to look at 3 over 2 and not just say, oh, it's just a number. Really, it's 2 different things. The top number is going to be usually the second step, whereas the bottom number, the denominator, is really going to be some sort of root. Now, when you go down here, very similar to the front, or the other page, it's just 2 different problems that are combined, and you might add or subtract them. But you do exponents first, add, subtract second. But I want to look at some of these that are fraction exponents, but also negative. So you recall that if negative is a reciprocal of sorts. Okay, so like number 8, you can break it up really 2 ways. I'm going to do it both ways, and you can see which one you like. Okay, so just watch this and see which one you believe is easier for you. So here we go. You can either do this, do 81 to the negative 1, right? And then to the square root of that, or you can do 81 to the 1/2 and then do the negative 1 after. So either are the same. You see how both of these multiply to negative 1/2, and it's just a matter of taste of what you feel more comfortable with. So some people like this, where it's going to be basically square root of 81, 9, and then have to raise that to the 1/2, which, recall, the negative just means reciprocal. So this is the same as 9 over 1, so the reciprocal will be 1/9. Okay. Or the second way here, you can do the reciprocal of 81, which is 1 over 81, and then raise that to the 1/2, or take the square root of it, and that's also 1/9. Because 1 over 9 times 1 over 9 is 1 over 81. So you get the same answer either way. Just know that there are different ways of doing these, so if you guys come back tomorrow and have different work, but your answers are coming out to be the same, this could be why. And as we do more problems, and you can look at the back of this sheet, they get more complicated, but it's nice because if it doesn't work one way, you can maybe try it a different way that you didn't try the first time, and it might be easier for you. So just be aware of that either way is fine, but of course you don't have to do both. But that'd be a very good bonus problem. Solve this, simplify this expression 2 different ways, and show that you get the same answer. Okay? So number 9 is very similar to number 8. Just do a cube root instead of square root. But let me look at number 10. Last one, or maybe the second to last one. Ready? Okay. So here, you've seen we have a different function for the denominator, for the numerator, and for a negative. So really you want to look at this and say there are 3 different functions you have to do on this problem. All these serve a different purpose. And you just usually see, negative 5 over 2 and just like, okay, that's negative 5 over 2 and negative 2.5, no big deal. But really you just want to break it up into different parts, and how you do that could depend or change the difficulty of it. So there's different ways of doing it. Most people like to start off with the root. That seems to make things easier, so they like to do this root part first. Okay? And then most people like doing the other exponent, which would be 5. And then lastly, just take the reciprocal of whatever you get, flip it to negative 1 power. Okay. So really 3 different things, and I color-coded it in a way that hopefully makes sense on why and how I did that. Now, can you change the order? Absolutely. You could have taken 4 to the 5th power, flipped it, and then find the square root. It'd be more complicated. Your numbers would be a lot bigger. So, know this. You will not need a calculator on this at all. If you start getting big numbers, change the order in which you're doing all your roots, and they won't get that big. So, for instance, if you did to the 5th power first, 4 to the 5th power, yeah, it's going to be in the tens of thousands. And then you're supposed to take the square root of that tens of thousands number. It's too big. So if that happens and you don't have a calculator, don't just say, well, I need a calculator to do this one. It's too hard. Change the order. Do the square root first, right? And you'll get something easier to solve. So like here you'll get square root of 4, which is 2. Right? Then raise it to the 5th power, which is 32. And then lastly, take the reciprocal. So that'd be 1 over 32. So what do you think? We should do another, or do you think you're good with this? One more. All right. 14? Okay, let's look at 14. Yeah. Or number 12. That's pretty good. Let's do 12. Okay, ready? So here we go. Same thing here, just break them up one at a time. So look at this, you want to recognize, well, this is one step, and that's the second step. And same thing here, we're going to have a 3. We're going to have this 2 here, but then because of a negative, we'll have a third step. 3 steps here. So the first one is to take the, let's see, 1/3 power. So we're going to have 8. I'll put that 4. We'll take this to the 1/3 power first, and we'll take the 4 to the 1/2 power. Then for each one, we'll do the numerator. So I'm going to raise that to the 4th power here and the 3rd power here. And then only on the second one, because there's a negative, we're going to raise that to the -1 power, or just do the reciprocal. And then at the very, very end, add the two numbers together. So it's really like two different problems, separate, and then very end, you'll just have two numbers and add them up. So let's finish this up. So we have 8 to the 1/3 power, which is the same as a cubed root. What times itself 3 times equals 8. We get 2. And we have square root of 4. What times itself 2 times? So 2. So first step, not too bad. Now, if you're looking at this and as you watch me do this and you say, well, I can do it when I watch it, it makes perfect sense. It's just when I try it on my own, I get confused. Now, ask yourself, are you writing everything I am? So, or are you saying, well, I like to do it in my head, I get stuck, therefore it's hard. So, write everything down and you'll see that it's not so bad. Yeah. Oh, there you go. Yeah. And it's not so bad. A second. So, this is to the 3rd power. So if it's getting confusing and you're just kind of going through it on the easy ones and saying, well, I don't really need to write that because I can do it in my head, here's where that kind of stops working, and you might have to do this no matter what. And if you were to look at the back, you'll see that they get even more so. So practice writing and showing out everything here, and it'll be easier later on. We got 16, and we have 8, and then the last one we just need to raise to the -1. Right, so we end up with 16 plus 1 over 8, okay, which of course is 16th and 1/8. And if you want to make that improper, that's fine, but that's simple enough, so we can keep it simple that way. Okay? All right. So your homework is to finish the front side only. Okay? And we'll talk about the back tomorrow.